Thank you very much for having me today. So, like that's been said, so my name is Herrick. So by the time I have applied for this talk, so I was working at Lotify, but now I have moved to another company. So yeah, so for the small presentation, my name is Eric. I'm a Google developer expert for Android. Currently, I am based in Montreal, and I'm working as a mobile developer at BRP. So BRP is a Canadian-based company which is creating a lot of recreative vehicle. And in today's session, I will try to give you a deep dive into Android system service. So within this talk, we will try to see what is the Android system services exactly and how to take advantage of it. So let's get started. So in case you have any kind of question, you can just reach out to me for my social media link by just scanning this QR code. So what is basically the system service? In order to be able to understand what is exactly the system services, it's important to understand to have a quick overview of the Android architecture. So the most of the time when you are trying to visualize the Android official documentation, you can find this kind of diagram that explain the different layers of the Android operating system. And the most popular one is this one. So you can see is from the bottom to the top, we have some different layer. And the most of the time as Android developer, we used to work with the top layer, the layer that contain all the API that we need to have when it comes to build our application. But on the bottom, right, you can see there is a kernel that do hold the binding to the hardware of your device. So it can be a phone or when any kind of device that can support the Android operating system. So the kernel will do all the binding to have access to the hardware. And there is this Java API framework that try to expose all those features of our operating system to the end user, which is, I would say, the developer who will have access to those API and try to build an application that can provide some set of feature to the user. But the most of the time, right, when you are working with a custom device, when I say custom device, I don't mean especially an Android device, a phone that is sold by, let's say, Google Pixel or any kind of device that you can buy in the store. I'm talking about a custom device that you can use. So in our case at BRP, we used to use some set of device that used to work on a vehicle, right? It can be a recreative vehicle such as a motor scooter or something like that, right? So we, in such kind of situation, the most of the time, the default implementation of the Android operating system doesn't provide to us all the necessary API that we need to use in the top level application that will be running on that particular device. And in such kind of situation, right, we need to create our own system service that will provide a set of API to the end user, to the developer especially, that we can have access to that particular API into our application. So basically, a system service play a key role in exposing the low-level function of the hardware. So, for example, in the Linux kernel to the high level. So it's basically the thing that I have just explained. So, for example, you can be in a situation when you are dealing with a particular device that have a non-particular hardware that is not pretty common for a normal device. And by default, right, the Android operating system will not provide the API to that particular hardware. So in that particular case, right, a system server will need to provide to expose that low-level feature to the top level, I can say. So by default, the Android operating system already have a lot of system services. You may probably know something like the alarm manager, the notification manager. All those API used to be linked to some low-level hardware that's tied to the device. So here is the example of some system service that we already have. There is something like the notification service, the alarm manager service, the power service, the battery service. There is a lot of them that already ready for use, and you can just ask access for them. For example, if you want to display notification, something like that, the most of the time we used to interact with the notification service. And one thing that is really particular with the system service is the fact that all the services, so most of them, right, used to be run in a separate process. What I mean by separate process, so the most of the time, your application will be running on a particular process, right? And the service will be running in another service. So a small example is, for example, the notification service. The most of the time we used to use the notification manager when it's come to display notifications to the user. But the notification service is not running into our application service, but it used to be running in another service. And there is a mechanism that is already there that can allow our application to communicate with another process, such as the system server. So basically here is the schema, right? I have my application, right? And the application have access to what we call a manager. So that is why the most of the time when it's come to display a notification, we use a notification manager. When it's come to set an alarm, we use an alarm manager. So the manager is running inside our application, but that manager will delegate the task that I will give it to him to a particular server that is running on a separate server. So the most of the time, a lot of those servers used to run in the system server is the name of the process that in which a lot of all those servers need to use to run in. And the most of the time, we need to have access to those services by using context.get system service by providing the name of that particular service. And we can have also something like this, right? We have a different kind of application. Let's say we can have 3 different applications that use the same manager. So it means that every single application in our device will have its own version, its own instance of the manager, right? But that manager, all those manager will be linked to one service. So let's say in application A, B, and C, I'm using the let's say the alarm manager. It will be 3 different instances of that manager, right? But all those manager will try to communicate with just one single instance of that of the alarm service, which is running into a separate process. And also we can also be something like this because the manager is linked to a context of a particular component. So for example, here we can have an application, right? But in the activity 1, for example, I'm trying to communicate with the alarm manager, but in another activity, I'm doing the same thing. So in this particular case, we can have in an application 2 different instances of the same manager, which will have access to a particular service. So it's pretty common, right? So we can have it's good to know that every time you have access to a particular manager, you are creating an instance of that manager, which will have access to one single service, which is running somewhere else. So basically, we can have something like this. On the top, we have the application process, right? So the set of process which is in which our application will be running. And inside that process, right, we can have a direct access to a different kind of manager based on the service that we want to provide to the user. We can have the package manager, the storage manager, the display manager, and so on. And those managers delegate all the tasks that we want to do to the particular service. So for example, the alarm manager will delegate it's called to the alarm service. So for example, here the storage manager will delegate to the mount service. And for example, the display manager will delegate to the display manager service, which has access to another service, which is not part to the system server. That's why I've said that all the system server is not running into the system server. There is some of them which used to run in a separate process. So for example, here for the camera manager, which is have access to the camera service, which is running into the media server. And how now can you create a custom system server? So it's not pretty common to be in a situation when you need to create a custom system server, but I will try to walk you through the process of creating that. So the first thing you need to do is to modify the AOSP codes, right? Because all those stuff need to be implemented into that. The first thing you need to do is to create an IDL file, right? So IDL means Android Interface Definition Language. So basically, this file will define, will be like a contract between the client and the service, right? And that contract will be like an agreement in order to communicate using the interprocessor communication mechanism. So let's say here I want to create a custom service. The first thing I need to do is to create a iCustomService.idl. You can create this file in Android Studio. And you have just to make sure that this file is in the package android.os, right? And it's basically the same syntax as the Java programming language. And in this case, I will create this interface with two methods. So the first one will just add A and B, and the second one will just return a name of the service. As you can see, I have created this file with the extension IDL. And like I have said, this file must be located in framework/base/core/java/android. So you have just to make sure that this file is in the right path. The second step, right, we need to create what I've called a stub, right? So here, it seems like there is a problem with my slide, but I think you can see there is a class, right, that extends to the interface that I've created, but it's not the interface itself, but it's a stub. So this stub will be generated automatically by Android Studio. So it will be a class that you can extend from the IDL file that we have just created. And this class will basically be the implementation of the interface that I've implemented. So for example, here I have used I have implemented my get servers name that return a custom string, and here for the add method I've just returned A plus B. And we have just to make sure that this file, the custom service.java, is also located into this path here. So framework/base/service/core/java. You have just to make sure that it's in the right package. So like you can see here, the package is com.android.server. And after that, you need to make sure that all those IDL files that you have created are located into the android.mk file. And this file can be found in framework/base/android into the AOSP code base, right? And you have just to make sure that you have put the full name of your IDL file. So in that case, the system will have the information that there is a custom service that has been added. And after that, we need to register to add our service to the system server, because like I have said, our service used to run in a separate process. And in this case, right, the only thing that we need to do is to call the service manager and to call the method add service. Here we need to provide the name of our service, and here we can just create the instance of the implementation of the IDL file that we have created. Is as simple as that, and you have just to put that in a try-catch block in case there is a problem. And you have just to make sure that this file can be found into the system server.java file, and you can find this particular file in this path. So the most of the time, as you can see, all the file that we are added and all the file that we are modified already exist into the Android system code. The step 5, right, we need to register our service in the context, because as you know, right, everything we have to get access to a particular service, the name of that particular service used to be in a constant variable that is present into the context.java. That's why the most of the time we need to do something like context dot the name of the service before calling that particular service. And in our case, we can just add a new line into the context.java by providing the name of that particular, just to make sure that this name is unique to avoid some set of conflict. And after that, we need to register. We can register our service in the system server register.java. So by doing that, we just need to call the method register server, right? The first thing that we need to do is to provide the name that we have defined into the context Java file. And then we need to specify the name of the manager. So like I've said previously, right, the application don't have a direct access to the service itself. So the application has access to the manager. And the manager is the component that will delegate all the action taken by the user to the particular service. That's why we need to have this link between the service and its corresponding manager. And we just need to use this kind of structure. So it's an existing method that you can call by providing, let's say, the name of the context, the instance of the manager, and inside this method you can just create, right, the object that represents the manager that will be linked to that particular service. And you have just to make sure that the file that we have just modified can be found into the framework /base/core/java/android/app. So just make sure to make this file into the right path in order to make things work perfectly. And after that, we need to create the manager. So the manager will be the component that will be running in the same process as my application. So for example, in our case, so our dummy custom manager that I've called the custom service manager.java, I can just put it into this path, right? So the user can have access to this quite easily. And now let's try to implement our manager, and you will see what will be the advantage of using the manager. So first of all, I will create a class. So a manager is basically a simple Java class, right? As you can see here, I will be creating an instance of my service, right? And here I will just make a mechanism. For example, if the service is null, I will create it. Otherwise, I will try to reuse the existing instance of my service. And after that, I will just need to create a method. So for example, here I can create a method getService, and that's use the service manager, right, to get the service by its name, right, the name that I've provided previously. So my service will already be registered to the service manager, so I can have access to it by using this method here. And as I can see, it returns an instance of the iBinder, and I can use that particular iBinder to initialize my service by using iCustom service.stub. Don't forget that this stub has been generated for us, and I just need to use the has interface method by providing to that method the binder, and it will return the service that I can affect to my mService object that has been created recently. And after this process, I can just return that particular service, and it can be used quite easily. And inside my manager, as you can see here, the manager don't do anything, right? So the manager doesn't have any kind of responsibility. The role of the manager is basically to delegate every single action that the user takes to the actual service. For example, here, every time the user will call the method getSystemName, basically the manager doesn't know the information the user is looking for. So the idea here, the manager will delegate this action to the server. So for example, here you can see I'm just calling the get service and .get service name. So I'm delegating this call to the service method, right? And the same thing here with my add method, right? The only thing I need to do is get service .had by providing those information, and the service will do all the computation and will return the results to the user. So as you can see, the manager is basically the bridge, I would say, between my application and the service itself. And inside my application, so what can I do? So basically it's quite simple. You probably use this method at least once because it's pretty common. So we need to do a get system service inside a context-based component. What I mean by context-based component, I mean it can be something like an activity. So inside an activity, I can have access to this get system service method, and I will provide the name of the context I'm looking for, right? And here, this method will not return the service itself, but it will return the manager, right? And from the manager, I can have access to this method that I have defined. So for example, the get service name. By calling this method, right, it will delegate to the actual service, right? And the service will return the corresponding response to this call. And the same thing here, so I can provide 1 and 4 and probably to return 5 as the result. And I can print out those information to the user, and the user can take advantage of all those information. So that is basically it. So that is the process that we will need to follow when it's come to implement a custom system service, because the idea here is being able to implement, right, to provide a new set of API that is not available by default in Android. And sometimes, the most of the time, we need to modify an existing service that is already available in the system. So in my company, we used to do a lot of things similar like this. The most of the time, that's why we need to modify or to create an existing system service. So the idea behind this mechanism, right, is being able to access some low-level feature, because the application and the system service will not be running at the same level of privilege, right? So, for example, you can't have access to the direct hardware from your application directly, right? You need to use this set of API that has been already implemented, this mechanism that has been set up for us, and you can set up all these things, and you know, to be able to provide some custom behavior to your application. So that's basically it. And just want to mention one last thing. It's really also important to be able to recompile the system, you know, to be able to ship that version of the system to your hardware in order to allow the developer of your system to be able to have access to those API. So that was basically it. And once again, here is the QR code that you can scan if you want to reach out to me on social media. And that will be it. Thank you very much.
Thank you very much, Eric. That was a great talk. If anyone has any questions, feel free to leave them in the chat, and Eric might be able to answer those. I did have one myself while we wait, in case there's any there. But I was curious, like, what's it's like debugging in these services. Like, I imagine there's probably a lot of very unique problems you can run into from the custom hardware you might be running on. And what's sort of the experience like working in those?
Yeah, the experience is quite tough, because those kind of things are not quite popular into the Android ecosystem, because if you try to find the documentation, is not easy. But the most of the time, the most of company who provide to us, let's say, some set of hardware, right, used to provide also to us some set of tools that we can use when it comes to debug. And there is a lot of mechanism that can be used, but the most of the time we rely on tools that has been provided to us by the company who created that particular hardware.
That makes sense. Yeah, they would be the ones who really understand how it was built. Cool. So it looks like we did get a question here. Can anyone apply all these concepts without buying a customized device?
Yeah, I think that can be possible because right now you can try to apply all these. You just need to have a device that is compatible with the Android operating system, the Android kernel, right? So there is a lot of custom hardware that you can buy on Amazon in which you can install you can download the Android code source on your device, and you can try to tweak a little bit by modifying one or two things, and try to there is a full documentation on that in the Android website, and but it's possible. So you don't necessarily need to have let's say, or you can even do that on an emulator, right? There is in the IOSP there is a lot of emulator that is already ready for use that you can use to experiment all these things.
Cool. Yeah, that's great. Be able to try these things out without having to make a purchase. Cool. I think that's all the questions we have for today. So thanks again, Eric, for the great talk. And this was great learning about system services.
Thank you.